Hi guys. Today I want to discuss my hypothesis on the distant timeline of the Great Pyramids and the Sphinx Basin. In my last video, I explained my reasoning on why the Giza pyramids and the Sphinx were likely created around the same era. My conclusion based on the topography and location placements of these structures, and the severe rainwater erosion marks around the Great Sphinx and the second Sphinx near the tomb of Kankas. I propose that the Sphinx sunken basin was probably part of an ancient industrial mining site and functioned as a stormwater catch basin to collect runoffs from a developed upper plateau where the Great Pyramids stand. The deep vertical water erosion marks on the Sphinx enclosure walls, the Sphinx body, the Sphinx temple, and the tomb of Kankas are conspicuous evidence that the Giza region experienced a more humid phase that lasted for a prolonged period. Since the Giza region has been in a desert climate from 6,000 years ago, this means the rainwater eroded structures were created in a previous humid time, and that would push the age of the Great Pyramid complex to a much earlier phase, before the dynastic Egypt, thus indicating that the pyramids and the Great Sphinx were the work of an unknown civilization. Additionally, multiple teams of researchers have discovered that the pyramid casings and core stones are artificial, concrete-like limestone, even containing nanoparticles. Hence, the Great Pyramids were constructed by an advanced civilization with a sophisticated concrete technology way before the dynastic Egyptians. Then, when were the pyramids built? Previously, I presented my theory that the long-term water erosion and the long-term wind erosion of the Sphinx Basin probably occurred in different times. The Sphinx Basin and the pyramids were possibly made during a relatively humid era. Later, the climate changed and became extremely dry and windy. During this time, some pyramid structures suffered from wind erosion. The Sphinx catch basin dried up and was inundated with sand. The pyramid maintenance crew repaired the sand-caused damages with more durable granite and basalt casings. It seems, however, that the restoration project was not complete and presumably abandoned, which might have been caused by the chaos and ultimate fall of the pyramid civilization. After a considerable period, the Giza site was rediscovered and reoccupied by ancient Egyptians. In order to figure out the pyramid's construction time, we need to find a period when the local climate transitioned from humid to super arid. Another factor to consider is what type of humid climate and what precipitation level could generate the water erosion marks on the Sphinx enclosure walls. Would a lot of rain be required to form these markings? The erosion marks of Giza monuments can help us narrow down the pyramid complex time frame by finding a matching paleoclimatic pattern. So, when were the Great Pyramids and the Sphinx Basin constructed? Here are my findings. Geologists generally agree that the intriguing water erosion marks around the Sphinx were caused by long-time rainwater and runoff draining into the basin. One may assume that the major damages on the limestone were the result of frequent rainfalls during a very humid period. Though that may not be the case. Let me show you some water erosion patterns that are similar to the ones on the Sphinx walls. These are photos of the Badlands. The gully erosion channels of the Badlands resemble the grooves on the Sphinx Basin, right? Badlands are a type of dry terrain where softer sedimentary rocks and clay-rich soils have been extensively eroded. Gully erosion in rock is more prevalent in semi-arid areas compared to really humid or super-arid regions. Because in humid areas, the more distributed rainfall usually allows for better vegetation establishment, which helps to mitigate erosion. While in very arid deserts, the sunken Sphinx Basin would be filled with sediments, whereby the basin walls would not have been exposed to erosion. Therefore, I believe the Sphinx Basin was initially excavated in semi-arid or relatively humid environments with sporadic rainstorms. Back then, vegetation covers were minimal and the basin walls were exposed. Thus, when major rainfall happens, the water rapidly flows over the terrain, concentrated runoff would have eroded the rock by creating rills and gullies on naked slopes of the Sphinx catch basin. Ergo, the pyramids on the Sphinx ditch were likely built in a semi-arid period with intense seasonal rainfall, which required a drainage system with a large catch basin. Semi-arid regions receive 10 to 20 inches or 25 to 50 centimeters of rain per year. Arid regions receive less than 10 inches or 25 centimeters of rain yearly. Hyper-arid areas typically receives less than 4 inches or 10 centimeters of rainfall annually. The Giza Plateau for the last 5 to 6,000 years has been hyper-dry with a yearly precipitation of merely 1 inch. Such a little rain cannot cause the gully erosion seen at the Sphinx enclosure walls. Yet the 10 to 20 inches of annual rain during a semi-arid phase would have been substantially different and able to generate the gully erosions seen on the Sphinx walls. As proposed in my last video, the pyramid civilization with concrete technology spanned from a humid to a dry period. And during the dry phase, the civilization declined and finally collapsed, thus erased from history. Centuries or millennia passed. The pyramid region was reoccupied by ancient Egyptians. To determine when the pyramids were constructed is to find a matching climate pattern in the Giza area, which started with an earlier, slight humid time and then changed to very arid. Generally, warmer temperatures lead to higher humidity, and higher humidity increases the likelihood of precipitation. Thereby, the warm phases are usually rainier, and the cold phases drier and dustier. Here is a graph showing the last few cold stages in the Northern Hemisphere. Younger dryas around 13,000 years ago. Henrik Stadium 1, HS1, 18 to 14.7 thousand years before present. And the last glacial maximum, roughly between 26,000 and 19,000 years ago. When was the relatively humid period that pyramids were built? Some might remember that I made a video on the impact of Green Sahara versus Desert Sahara periods to the Giza region. North Africa has been through many green and desert cycles. The last African humid period, also known as the Green Sahara, lasted from 15,000 to 5,500 years ago, during which the Sahara was characterized by grasslands, lakes, and rivers. As we see on the map, the significantly wetter condition of the last African humid period caused by monsoon precipitation did not reach to the Giza region. Giza is by the Nile Delta of the East Mediterranean and has been on the border of the Mediterranean climate. Local climates can be profoundly affected by many factors and may not always align with the geographical conditions. For example, the Younger Dryas was a period of rapid climate cooling that occurred around 13,000 years ago. Many regions got very dry during this era, but strong regional patterns in parts of the Near East and the Mediterranean have overruled the Younger Dryas signal. Multiple studies discovered that the Younger Dryas appears to have been cold and wet in many Mediterranean places, which was possibly influenced by the ice sheet. Even in the East Mediterranean area, different places might experience distinct local climates, which is confirmed by various sediment core studies. Because local climates can be quite different from the global or large regional climatic trend, we cannot rely on the big picture data for the pyramid's timing, but should zoom into the Giza area. A sediment core, MS27PT, is so far the closest to the Nile Delta, which means it likely contains the best data available on the paleoclimate of the Giza region. This core has been investigated by many teams using all kinds of methods, including a 2023 paper which I reference herein. This paper provides interesting information on the precipitation in the Nile Delta utilizing this core since the last glacial 18,000 years ago. It states that in the Delta area, the infamous cold and extremely dry event, Henrik Stadium 1, evolved into two phases, with a dry episode between 17.5 to 16,000 years ago, followed by wet conditions between 16 to 14.5 thousand years ago. Data from the Sorek Cave, Israel, suggests a progressive increase in precipitation at the same time. After that, relatively dry conditions prevailed in the Nile Delta for about 3,000 years. This was followed by a much wetter climate from 11,500 to 6,000 years ago. Previously, HS1 was regarded as a millennial-scale cold and dry events across regions like North America, Eurasia, and North Africa, though there is a growing view that HS1 divided into two phases with a succession of dry and wet episodes. To arrive at a broader and more robust paleoclimate data for Giza pyramids, I checked 5 scientific papers which investigated climatic conditions that are close to the Nile Delta to see if they share a similar pattern. Among these reports, 3 of them studied the Nile Delta and were East Mediterranean sedimentation using drilled cores, including MS27PT. 2 compared oxygen isotope records from speleothems of Sorek Cave with cores drilled in the East Mediterranean, and 1 analyzed rock varnish and lake water levels in the Dead Sea Basin. I won't swamp you with the details, and will just present a summary. If you want to read these papers, the links are in the description below. In short, there is general agreement on the wet and dry phases in the Nile Delta region close to the Giza pyramids. Here is the summarized timeline of the dry and humid periods from 5 papers. Let's start with the most ancient on the right. During the notably dry conditions of the last glacial maximum, there was a relatively humid period between 22.5 to 20.5 thousand years ago, succeeded by a very arid time between 20.5 and 16,000 years ago, which covered the first phase of HS1. Then a relatively humid period arrived and lasted until 14,500 years ago. This was followed by another dry era for a few thousand years, and then a more humid time from 11 to 6,000 years ago. For the most part, the climate patterns are synchronized, albeit the dating results deviate a little bit. The 2020 paper is the only one that showed an extra brief wet phase. If we ignore this outlier, we can see that within this framework, there are 3 humid periods, and each lasted for a few thousand years. The early Holocene humid period, the HS1 second humid phase, and the last glacial maximum humid time. Please note that the 2 earlier wet phases were in cold weather and thus not as humid as the Holocene one, which means they are actually better fits for the semi-arid climate conditions that can generate gully erosions on the Sphinx enclosure walls. Now, what humid period can be the pyramid's construction time? Let's check out the most recent one first. In this case, we assume that the pyramids were built between 11,000 to 6,000 years ago. Then a dry and windy climate took over, and during this time, the pyramids and temples suffered from centuries of wind erosion in their lower portions, which then prompted the pyramid crew adding granite casings as repairs. Next was the ending phase of the pyramid civilization. The fall of a sophisticated civilization which was capable to construct multiple massive pyramids would not have been quick. There would have been attempts to revive and prolong the society. Conceivably, it took a long time for this culture to decline and eventually collapse. Pre-Dynastic Egyptians arrived in the Nile Valley around 6,000 years ago, which means their time would have overlapped for hundreds of years with the pyramid civilization. If ancient Egyptians coexisted with the pyramid civilization, then there should have been folklores, legends, or historical records on this impressive culture, as well as archaeological evidence, if such an advanced civilization only ended less than 6,000 years ago. Yet there is neither records nor archaeological findings to attest to this. This implies that the 11 to 6,000 years ago humid period was not the right answer. We have to look further into the past, to the 2 earlier humid eras. Both time frames could potentially work, as they have sufficient time spans for the pyramid construction, restoration, and fall of its civilization scenario. a relatively rainier period that could generate the heavy water erosion marks around the two sphinxes, which was succeeded by a long-term windy and dry phase that caused damages to Giza's structures that were later repaired. The harsh millennia drought might also be the downfall of the pyramid civilization. In both scenarios, the advanced civilization ended over 5,000 years before the arrival of pre-dynastic Egyptians. Such a long time can erode, erase, and bury most evidence. This could explain why there is no archaeological evidence, records, or legends about the pyramid builders and how the pyramids were constructed. Between these two humid phases, which one could be the time of the pyramid civilization? Let me introduce another piece of the puzzle, the human population bottleneck. You might recall this from one of my prior videos. Whichever civilization erected these immense and precise pyramids with artificial stones must have been very sophisticated and capable. Likely an industrial culture with advanced mathematical, engineering, and material knowledge. To reach to this high level, a civilization ought to have developed over a long time and have had a sizable population to provide and supply the required ingenuity and human resources. This means the ending of this civilization, along with its people, should have left some mark in the human genome. We should notice a population decline during that time. According to a paper written by the 1000 Genomes Project, for the entire existence of anatomically modern humans, there was only one worldwide population decrease critical enough to be regarded as the ending point of a previous advanced civilization. That was between 20 to 15,000 years ago. During this perilous time, all human populations outside Africa experienced a severe reduction. Ancient African populations also dropped significantly, though less alarming. Could this be the fall of the pyramid civilization? This human population bottleneck came after the relatively humid phase in the last glacial maximum and coincided with the 4,000 years of drought in the northern hemisphere. Approximately 68% of the Earth's landmass is located in the northern hemisphere, and the northern hemisphere is a major producer of key food crops. During the 2018 to 2022 crop years, the northern hemisphere accounted for 88%, 45%, and 91% of world corn, soybean, and wheat production, respectively. Today, about 87% of the world's population lives in the northern hemisphere. The widespread millennia-long drought across the northern hemisphere would have been devastating to any civilization. The first phase of HS1 has been proven to be extremely dry, and this unprecedented super drought might have led to loss of both food and water resources, worsened living conditions, which in turn may have spawned pandemics, triggered territorial conflicts, and cycles of famine and war. This could be why the previous industrial civilization, which designed and constructed the pyramids and many other megalithic sites, ultimately failed. You might wonder what happened after the fall of the pyramid civilization. Could any of their people survived or migrated? Well, genetic analyses uncovered that between 19 to 14,000 years ago, there is evidence of major population shifts in both Europe and East Asia, with existing populations potentially being replaced by new groups after the glacial period. People who lived in Europe and East Asia from 40 to 45,000 years ago were wiped out and replaced by new people after the last glacial maximum. These newcomers are the ancestors of current Europeans and East Asians. It's not pure coincidence that the population bottleneck and the population replacement happened consecutively around HS1. With all this information considered, I think the Great Pyramids were likely constructed during the 2,000-year relatively humid period in the last glacial maximum, between 22.5 to 20.5 thousand years ago, when the average temperature was about 7 degrees Celsius lower than now. The sunken Sphinx ditch was a catch basin for the Giza mining site, excavated during the semi-arid climate with seasonal rainstorms. Although the humidity level was higher, the cold temperatures greatly affected plant establishment at Giza. With little to no vegetation cover, the runoffs of the plateau left deep water erosion marks on the Sphinx basin walls. Then the local climate changed to hyper-arid. The pyramid civilization did not survive the 4 millennia-long severe drought and ended around 15,000 years ago. The Giza area was repopulated about 9,000 years after by a new group of people, the ancient Egyptians. By that time, most traces of the pyramid civilization had decayed, became buried, and were long gone. Only their massive earthly structures, like the timeless pyramids, remain to remind the world of their past glory. What do you think? If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.